Hi everyone, welcome back. We're going to look at factoring trinomials using a method that's referred to as the Columbia method. And it's used when the term of the coefficient of x squared is not 1. If it's greater than 1 or if it's less than 1, if it's anything other than 1. I also provided the answers for the last check your understanding, so please make sure you took time to factor A, B, and C. If you'll notice letter C, there was a greatest common factor and it was -3. So when you factored out a -3, you were left over with x squared plus 5x minus 14. And then this actually factors further. So you're looking for two numbers that multiply to give you -14 but add to give you a 5. And that would be a 7 and a -2. 7 times -2 is -14. 7 plus -2 is 5. So your final answer is this. So now what happens when the coefficient of your squared term is not 1, like in letter A? It's 6x squared minus x minus 12, and we need to completely factor. So we're going to look at the steps. Step number 1 says multiply your A and your C together. So A is 6, C is -12. If I multiply 6 times 12, I get 72. So I'm going to rewrite my problem with A times C. So now you're going to multiply, you're going to factor using the same steps we just did. You need two numbers that multiply to give you -72, but add to give you that middle term, that B term, -1. Remember the rules for the signs, write down the first sign you see, and then multiply the signs together. So the first sign I see is negative, and then a negative times a negative is a positive. So you know you're going to have a negative and a positive. And it doesn't matter which one is which in the x, okay? The numbers do matter though. So now you need two numbers that multiply to give you -72, but add to -1. So what that tells me is if they need to add to -1, they need to be one number apart from each other. So think of numbers that divide into 72 where they're only one away from each other. And that would be a 9 and an 8. Okay, so now which one gets the negative? When I add them, it needs to give me a -1. So that's going to be a -9 and a +8. Okay, -9 times 8 is -72, and -9 plus 8 is -1. So just like we did before, we're going to write our factors like this. Okay, except now we're going to go to step 4, which says divide each term in both parentheses by A. Sometimes this is referred to as like slide and divide. So I'm going to divide each of the terms by my A value. Remember, A is 6. Okay, it's that first term there. It's ax squared plus bx plus c. Okay, and the next thing I want to do is reduce it if I can. So I can reduce 9 6, right? 3 goes into 9 and 3 goes into 6. So 3 goes into 9 3 times and 3 goes into 6 2 times. Okay, and don't worry, we're not going to leave it like that. And then I can divide 2 into 8 and 6. So 8 divided by 2 is 4, and 6 divided by 2 is 3. So now, if they don't divide evenly, we slide and divide, okay? And then we take the number on the bottom, and we slide it to the top. So this 2 is going to go up to the top here. And this 3 is going to go up to the top. So your final answer is 2x minus 3 times 3x plus 4. Okay, and again, you can check this by foiling. So to FOIL, right, we would do first times first, 2x times 3x is 6x squared. And then I'm going to do my outer terms, which are 2x times 4, that's 8x. And then my inner terms, -3 times 3x is -9x. And then my last terms, -3 times 4 is -12. And I can combine the net 8 and the -9. 8 minus 9 is -1. So your final answer is 6x squared minus x minus 12, which is the problem that we started with. So you know your answer is correct. So here is your final answer. Okay, those factors will give you the product 6x squared minus x minus 12. Being able to do this is very important for any future topics we talk about. So you really want to make sure you practice, and it's okay to keep practicing until you are comfortable with these types of problems. Okay, so let's try another one. So here I have 4x squared plus 5x minus 6, and I want to look for greatest common factor, which I don't see any. So I'm going to do the Columbia method. I'm going to multiply my a and my c together. So 4 times 6 gives me 24. So my new problem looks like this. So now I want to do what I've been doing. I want to find two numbers that multiply to give me negative 24, but add to give me that middle term, that 5. Okay, I'm going to use my rule for my signs. I've got a positive. I'm going to write down the first sign I see, and then multiply my signs together. Positive times negative is negative. So I want two numbers that multiply to give me negative 24, but they have to add to give me 5. Okay, and that would be an 8 and a negative 3. 8 times negative 3 is negative 24, and 8 plus negative 3 is 5. So now we're going to put those into our parentheses, like so. So we'll have x plus 8 and then times x minus 3. And then don't forget, I need to divide those terms, the 8 and the negative 3, by my a, because we multiplied by a, so we have to undo it. So we're going to divide by 4. Here, 8 divided by 4 is 2, so that's easy. 3 and 4, I can't simplify those, so remember the 4 just goes to the top. So it would be 4x minus 3 for your last factor. So my factors are x plus 2 times 4x minus 3. In letter C, the first thing that stands out to me is they're all even numbers, so I know I can pull out a 2 for my GCF, and all of them have an x. We take out the lowest one, which would be x to the first, and they all have a y, so we're going to pull out a y as well. So my greatest common factor is 2xy. I need to pull that out of there before I factor it. So my leftovers would be 12 divided by 2, which is 6. X cubed divided by x is x squared. And then y divided by y just cancels. Negative 22 divided by 2 is negative 11. X squared divided by x is x. The y's cancel. 8 divided by 2 is 4. And then the x and the y both cancel. So I'm left with 2xy times the quantity, 6x squared minus 11x plus 4. And what I need to do now is, since the coefficient of x squared is not 1, I need to use the Columbia method. So the difference is that I'm going to carry this GCF down. Okay, we're going to multiply a times c together. Okay, so I want two numbers that multiply to give me a positive 24, but they have to add to give me a negative 11. And your signs are going to be a negative and a negative. Okay, because the first sign I see is negative, and then if you multiply them together, a negative times a positive is a negative. So negative 8 times negative 3 gives me positive 24, and negative 8 minus 3 is negative 11. So I'm going to rewrite this as 2xy times x minus 8 times x minus 3. And then don't forget, I needed to divide by a. But a this time is not 12, right? We reduced 12 by pulling out a greatest common factor. A is now 6, so I'm going to divide all of these numbers by 6. Remember, the GCF, you're not doing anything with that, you're just carrying it down. Okay, and I'm going to reduce, so 8/6 reduces to 4/3. And 3/6 reduces to 1/2. And then the only other step to do is remember to take the denominators and slide them up to the top. So your final answer would be 2xy times 3x minus 4 times 2x minus 1. Okay, I'm going to give you the answers for the check your understandings, and I strongly suggest you try to factor these to make sure that you are good with those before moving on. Okay, we're now going to look at a special type of factorization. These are called perfect square trinomials. So if you can identify them, it will make the problem much easier. Perfect square trinomials have to have the following two conditions. The first and last terms have to be what we call perfect squares. So a perfect square is just anything you can take a square root of. Like the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on. Okay, they're your perfect squares. And then the middle term is twice the product of the square roots of the first and last terms. Okay, so what does that mean? So let me give you an example. If I had something like this, x squared plus 6x plus 9, that's a perfect square trinomial because it fits the two conditions. Okay, there have to be two perfect squares. 1x squared, 1 is a perfect square, and 9's a perfect square. I can take their square roots. So if we follow these formulas here, right, we have a squared plus 2ab plus b squared, and it will factor into this. Or you could get a squared minus 2ab plus b squared, and it factors into that. Notice that the a squareds and the b squareds are positive in both cases. There can never be negatives here in front of the a squareds or the b squareds. What you can do is try to factor a negative 1 out, or it just wouldn't be a perfect square trinomial. And then you would use one of the methods that we talked about earlier. Okay, so I've got my a here would be 1x squared, and my b would be 9. So if I take the square root of x squared, you just get x. And if I take the square root of, so let me put my a squared, so a is x and b is 3. The square root of 9 is 3. Okay, and then using the formula, it's just going to be a plus b squared. So, okay, how do I know this is a perfect square trinomial? I have to have two perfect squares, which I do. X squared and 9 is a perfect square. And then we said the middle term. How do I get the middle term? It's twice the product of the square roots of the first and last terms. So you're going to take the square roots that you just took, okay, x and 3, and just multiply them by 2. So twice the product, product means multiply, of the square roots of those terms. So 2 times 3x gives me 6x, okay, which is what I have as my middle term. So you know that's a perfect square trinomial. So to factor it, it's just going to be a plus b squared. Okay, remember x plus 3, that quantity squared, means x plus 3 times x plus 3. And 3 times 3 gives you your last term, which is 9. And 3 plus 3 gives you your middle term, which is 6. So that's why it's a special type of trinomial that factors pretty easily. So let's try these next two. So first we need to determine, is it a perfect square trinomial, and then factor completely. So I need to go through my two conditions. The first condition is, do I have two perfect squares? 1x squared and 49. Can you take the square root of them? Okay, I can take the square root of 1x squared. It's just x, so that's my a. And the square root of 49 is 7, so that's my b. So yes, it is, I have two perfect squares. I'll call them PS. And then you need to check the middle term. So the middle term is twice the product of the two square roots of your a and b squared terms. So 2 times x times 7 gives me 14x. And that's what I have for my middle term. So you know that you can factor this as a perfect square trinomial. So since it's x squared plus 14x plus 49, I'm just going to have a plus b squared. Okay, my a is x and my b is 7. And then you're going to square it. So it's x plus 7 squared, which remember just means x plus 7 times x plus 7. Okay, for letter B, same thing. I'm going to check to make sure I have two perfect squares. Can you take the square root of 16x squared? And can you take the square root of 25? The square root of 16x squared is 4x, and the square root of 25 is 5. So I've got my two perfect squares. Now I need to check the middle term. The middle term is twice the product of your a and your b term. So if I multiply 2 times 4x times 5, 4x times 5 is 20x, 20x times 2 gives me 40x. So I do get the middle term. Notice this time, though, the middle term is negative, so we're going to be following this formula. It's a minus b squared when that happens. So here, it's going to be your a, which is 4x, minus your b, which is 5 squared. So it's 4x minus 5 squared. My next type of special factorization is what's called a difference of two squares. So for a difference of two squares, we already talked about perfect squares. Okay, you have to have two of them, and then you have to have a minus in the middle. Okay, difference of two squares factors into a plus b times a minus b. So if you look at all of these problems, except for letter D, all of them have two perfect squares. You can take the square root of each of those terms, and they all have minuses. Even letter D does. The only difference with letter D is 20 and 125 are not perfect squares. So here, A would be equal to the square root of y squared, which is just y, and B is equal to the square root of 25, which is just 5. So this is just going to factor into y minus 5 times y plus 5. In letter B, the square root of 9 is 3, and the square root of m squared is m. And the square root of 49 is 7. So this is just going to be 3m minus 7 times 3m plus 7. And it doesn't matter if you put 3m plus 7 first and then put 3m minus 7 second. Remember, multiplication is commutative, so you can multiply in any order that you want. Okay, in letter C, the square root of x squared is x. The square root of 16y squared is 4y. So now I'm going to have x minus 4y times x plus 4y. And in letter D, the very first thing you should do here, since you see two terms, but they're not both perfect squares, like 20 and 125 are not perfect squares, they might have a greatest common factor. So think about numbers that go into 20 that also go into 125. And if you think about it, 5 goes into both. So 5 is your greatest common factor. So I'm going to first factor that out. 20 divided by 5 gives me 4x squared. And then 125 divided by 5, and it's negative, would give me negative 25y squared. So now your a is going to be the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. And b is the square root of 25 is 5, and the square root of y squared is y. So now I just have 5. That 5, the GCF just carries down, and you'll have 2x plus 5y times 2x minus 5y. And again, it doesn't matter if you put the plus first and then the minus or vice versa, but that would be your final answer. Okay, and then you can try each of the problems underneath the practice, and I'll give you the answers for these so you can check them. Okay, so please pause the video and try factoring those. We only have one more type of factorization to do, and this is called a sum and difference of two cubes. So when we're dealing with cubes, right, we just finished talking about squares. Cubes are numbers you can take the cube root of. Like 1 is a perfect cube because 1 times 1 times 1 is 1. 8 is a perfect cube because the cubed root of 8 is actually 2 because 2 times 2 times 2 gives you 8. 27 is a perfect cube because the cubed root of 27 is 3 because 3 times 3 times 3 is 27, and so on. Okay, so if you look at the way we factor, you can add 2 cubes and subtract 2 cubes. And if you're adding 2 cubes, you're going to have a plus b times a squared minus ab plus b squared. And if you are subtracting, the only difference is there's a minus here and a plus here. Okay, so there's an easy way to remember the signs, and it's just remember the word SOAP as an acronym. It stands for same sign, opposite sign, always positive. So what I mean by that is if you have a sum of 2 cubes, it's going to be the same sign. So if this is a sum, it means add. So you're going to have a plus. And then it's opposite sign. So you're going to have the opposite of a plus is a minus. And then always positive goes together. So the last terms are always positive. So if you have a difference of 2 cubes, right, we have a minus. Same sign, and then the opposite would be a positive, and then always positive at the end. Okay, so let's try one of these. So I have 8x cubed minus 27. 8 is a perfect cube. 8x cubed is a perfect cube because the cubed root of 8 is 2, and the cubed root of x cubed is just x, because x times x times x is x cubed. And 27 is a perfect cube. 3 times 3 times 3 is 27. Okay, so now I'm going to apply, since I am subtracting, I'm going to use my difference of 2 cubes formula. So the difference formula says do a minus b and then a squared. So if I take a and I square it, remember we have to use a product to a power rule for exponents. So you have to raise this 2 to each of the numbers get raised, or each of the, whether it's a number or a variable, gets raised to the second power. So this is really 2 squared x squared. Okay, so 2 squared gives me 4x squared. And then it says opposite sign, so plus, a times b. So if I multiply a times b, 2x times 3, I get 6x. And then it's always positive, plus b squared. And 3 squared is 9. So that's your final answer. It's 2x minus 3 times 4x squared plus 6x plus 9. For our last one, let's look at a sum of 2 cubes. So 64x cubed is a perfect cube because I can take the cube root of 64. I can also take the cubed root of x cubed. So the cube root of 64, x cubed is just 4x because 4 times 4 times 4 is 64, and x times x times x is x cubed. And then the cubed root of y cubed is just y, because y times y times y is y to the third. So using my rule for the signs, right, it's SOAP, so it's same sign, and then it's opposite sign. So what's the opposite of a positive? It's a negative, and then always positive. And if I look at my formula, it just goes a plus b times a squared minus ab plus b squared. So a plus b, and then a squared. So remember, you're squaring 4x. So that means you have to distribute the exponent, right? 4 squared is 16. And then if you square an x, you get x squared. So this is 16x squared minus a times b. So 4x times y is just 4xy. And then b squared. So b is y, and if I square it, I get y squared. And then that's your final answer. And then there's some practice problems for you all to try. So I will give you my answers here. And I strongly encourage you to try these and be sure that you understand them. Okay, if you have any questions, please reach out to me. Please don't get discouraged with factoring. You really have to work at it and practice to feel comfortable with it. But it is a very important skill to have to be successful, especially in any future math classes, but also in the next topic we're going to cover, which is rational functions. We'll be using factoring quite a bit there. So please make sure you practice and feel comfortable with these things, and please reach out if you have any questions. Okay, hope you all enjoy the rest of your day.